Okay, hello everyone. My name is Mr. Burke. I teach statistics at a number of community colleges in Southern California, and the purpose of the lesson today is the subject of confidence intervals and how we write a confidence interval where we use a sample mean to make a prediction about a population mean. Now, the purpose of the lesson today is to not teach the entire subject, as we already have videos to do the introduction of the topics. Rather, this is to augment the introduction to the lessons to help students actually go through the questions and better understand how they're done in context. So remember, what is the purpose? We use a sample mean, which is usually provided in the question, or has to be calculated, to make a prediction of what the population mean is going to be. If you watch my previous video about sample proportions or predicting population proportions, you'll notice that we calculate a sample proportion to estimate what the population proportion is. Here, we use a sample mean to estimate what we believe the population mean of something is going to be. So there is some consistency in terms of the language and how we characterize what we use and what we're trying to find. So let's go ahead and read the first question here. And again, this is from the Triolo, California 2nd edition book. And you've found the corresponding problem number from your textbook if you'd like to take a look at this for yourselves. Okay, birth weight of boys. Use a summary statistics for birth weight of 195 boys. This is the sample mean as we give it by x bar, which is equal to 32.7. I want to say that's going to be like a hectogram. I've just never seen like the weight given in hectograms before. Okay, I'm not used to seeing that usually. And a hectogram, in case you're not familiar, a hectogram is like 100 grams. That would translate to basically be 3.2 kilograms, in case you're interested. So don't let the HG throw you. Okay, so 32.7 hectograms is equal to 3.27 kilograms. All right, so just want to kind of explain that to people. Remember that a kilogram is about 2.2 pounds. Okay, so don't worry about the number so much. At least we have the same, hectograms used both in the sample mean and the standard deviation, and the sample standard deviation. One more thing I should have before we go on to is that in the questions that I'll provide both on the homework and on testing, the questions will always assume that the population standard deviation is not known. That's important because that's going to require us to use what's called a student t distribution to generate this. And you'll see that on the calculator we're going to use what's called a t interval program to help us calculate everything. So we have here that the sample mean is equal to 32.7. The sample standard deviation is equal to 6.6, and then and that n is going to equal 195. And it says the confidence level is going to be 95%. So CL is going to be 0.95. All right, so let's go ahead and take a look to see how this is done on the calculator. So we go to the calculator and notice we go down to go down to 8 where it says t interval. We only use z interval in the instance that we know from prior experiments what the population standard deviation is, which is not going to be what I'm going to be showing. So we're not going to use z interval here. Okay, so we press enter for this now, and you'll notice here that you have two possible choices for this. So what I'm going to do with my paper here is I'm going to just put t interval, and I'm going to choose stats, meaning that I'm basically being provided with the summary statistics in order to do this question. So I can put t interval stats, and then I'm given x bar, s, n, and then the confidence level. Same information that I already have to the right here. Okay, so that's going to be 32.7, 6.6, 195, and then 0.95. And I'm going to go ahead and put this information into my calculator. So 32.7, 0.66, 195.95. Okay. And again, what you'll see the calculator generate here is going to be an interval shown in parentheses. So it's going to be 32.607 to 32.793. Notice here, not a huge difference. So this is like a pretty small and tight confidence interval here. Okay. It also provides you with the sample mean, well, which we already have. So no surprise there. We don't have to indicate that. So what I want you to do next is we're going to go ahead and write out what we believe the population mean to be. And we're going to use the symbol for the population. Write this again. That's going to be mu. And we're going to round this just, now in this problem here, because our information, like our mean is given to one decimal place, our standard deviation is given one decimal place, we're going to go ahead and write each of these to one decimal place then. So this would be 32.6, and this is going to be 32.8. And I feel like those numbers are just... I feel like those numbers are really small. I'm just going to check my work again to make sure I didn't put anything inaccurate. 0.66. Oh, yeah, they are. Yeah, it's going to be 6.6. Yeah, I felt those numbers were really small. So I'm going to go back and revise my work. So this is where it's really important to check your work. So I'm going to check just show that here. So my standard, or my confidence interval is going to be 31.768, comma 33.632. If I round this and show this, the confidence interval using this framing, this is going to be 31.8 to 33.6. So my confidence interval that I usually write, and you should be ready to write either like this or like this, is 31.8 is less than mu, which is the true population mean, which is less than 33.6. So again, we're going to write a conclusion for this. I'm going to go ahead and write this here. We're going to say we are 95% confident that the true population mean for birth weight of boys is between 31.8 Hg to 33.6 Hg. Okay, so you'll notice here that the way in which we write this statement is very similar. If you watched the previous video, the way in which we write this statement is very similar to how we wrote the statements. We were writing an interpretation of a population proportion. Okay, we're going to examine two other questions. The second question is going to use the same thing. We're going to use a t interval, but we're going to use it a little differently. Okay, so questions on speed dating. So it says, in the study of speed dating conducted by Columbia University, male subjects were asked to rate the attractiveness of their female dates. And a sample of the results are listed below. 1 equally not attractive, to 10 being extremely attractive. Use a 99% confidence level. What do the results tell us about the mean attractiveness ratings made by the population of adult females? Okay, so let's go ahead and we'll see in this information here that we're given a list of data. So to do this question on the calculator, notice here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in order to do a to develop a confidence interval based on this data, we actually need to put this in a list on the calculator. So all of this is going to go into list 1. Okay. The other thing we need to acknowledge is the confidence level in this case is going to be 0.99. So let's just see how we do a question like this. So first off, we're going to go to stat, and we're going to edit our list. And if there's any information in there, you need to clear it out. If you know how to do that, just go up to the list, hit clear. Don't hit delete. Just hit clear. And we're going to go ahead and type that information in now. So it'll be 7, 8, 2, 10, 6, 5, 7, 8, 8, 9, 5, 9. Okay. So I have 2, 4, 6, 8. So I have 12 sets of data, 12 numbers in there. So that matches up. You always got to be careful to make sure you're putting in the correct data in. So let's say I have 7, 8, 2, 10, 6, 5, 7, 8, 8, 9, 5, 9. Okay, looks good. So now if I want to run a test on this, or to find the confidence interval, I'm going to hit stat, arrow over to tests. I'm going to go down to 8. That's going to be a t interval. For this time, I'm going to choose data. Okay, so when I'm doing this now, let me bring my calculator over here. I'm going to go ahead and run a t interval. This time I'm going to choose data. And I have to make sure I press enter. And what you notice is that the input's going to be a little different. So my first thing it's going to ask for is my list. This is the location of where you have the data. Now the default choice for this is going to be L1. And most of the time that's where it's going to end up. Sometimes students delete L1 if they use a different list. If that's the case, then you go to second and then you press like number 2 for list 2. So let me show that again. So if you want to choose a different list for some reason, hit second and then choose like 2 to go to L2, or second and 3 to choose L3 if you need to do that. Frequency, for this one, the default is 1. Leave it 1. Don't mess with it. And then the confidence level. In this problem, it's actually going to be 0.99. Okay, so let's put 0.99 here, and we're going to calculate it. And what we notice in the question, and I'll just kind of put this over here, is that the confidence interval we're provided with is 5.0135 to 8.9865. Okay. Now, we look at this here. Now, this is what the calculator is generating it. When we write it, we want to follow conventional rules of how we round like mean and standard deviation. So let's say in this particular problem, we're working with whole numbers. So that since we're working with, we want like the mean or what we think the population mean is going to be, we're going to round each of these numbers to one level of greater accuracy. So if these are whole numbers, each of these needs to be rounded to one decimal place. So this is going to be 5.0. And 8.90, that's going to be 9.0. So you can't just write 5. I know that says 0, but if you write just 5, that's going to imply that no rounding is needed. It's exactly 5, which is usually not going to happen. Same thing here. I know this rounds to 9.0, which is like 9, but if you have just 9, that implies that it is exactly 9, which is not the case. So now that we have a proper confidence interval for our estimation of the population mean for attractiveness, we need to write a statement for this. So we are going to say here, we are 99% confident. See, that's different now this time because we have a different level of confidence. We're 99% confident that that the population, the true population mean for level of attractiveness of women is between 5.0 to 9.0. Now they don't give a scale like it doesn't say one is a gram or an inch, just between 5 to 9. And that's we go in and write interpretation of this particular situation. So again, this is how we use the calculator when we're given a list of data. We put this data into list 1, and then we have to make sure to choose the data part. under T interval to be able to access that information and to come up with what we need. One other thing here too is if you take a look at the calculator, it'll give you what the sample mean is. And it says that X bar is equal to 7.0, which seems about right because it ranges between 5.0 to 9.0, so it makes sense that the sample mean is in fact 7. Okay, so now one more thing I'll specify here. It says here that the sample mean is equal to 7, like it's actually 7 precisely. So if you wanted to say that this was 7 and you wanted to show it, that would not be inaccurate. You're supposed to round this to the nearest tenth if rounding is needed, but because it's actually 7, then you don't necessarily have to put the 0.0. So just thought I would include that little tidbit of information. Okay, question 11. Okay, so this data set includes a sample of 106 body temperatures having a mean of 98.2 and a standard deviation of 0.62 degrees Fahrenheit. Construct a 95% confidence interval. Construct a 95% confidence interval estimate of the mean body temperatures for the entire population. What does the result suggest about the common belief that 98.6 is the mean body temperature? I'll talk about that because I know it's the common belief, but I'll explain why this is not true, but it is significant for a very important reason, especially these days. It is in July 2020 in the midst of a pandemic. So we'll discuss that in a little bit once we see the results of this. So we have 160. Let's see, 106 participants here. So, but we have a sample of mean of 98.20. We have a sample standard deviation of 0.62. So notice here, these are rounded to 2 decimal places. That's going to impact how we round our estimate of the population mean. N is going to be equal to 106. The confidence level is going to be equal to 0.95. So again, when we put this into the calculator, we're going to have the T interval. We're going to put this under stats. And we're going to put this information as is, and this is going to generate a confidence interval in the form of using the parentheses. So let's go back. Oops, nope, stats. And let's type in 8 again. Here we go. So this time we're going to go stats. Make sure to press enter so we have the proper fields in stats to enter. This is going to be 98.20. Now the calculator is going to take that 0 away. That's fine. N will equal 106. Confidence level is going to be 0.95. We're going to press calculate. And we'll notice the calculator gives us the following answer to this here. So it's going to be 98.081, and it's going to be 98.319. Okay. When we want to show this, we want to know is how many decimal places do we round this? Well, if the sample mean and the sample standard deviation are both rounded to 2 decimal places, we're going to round these results to 2 decimal places also. 98.08. This is going to be 98.32. Okay, so this is the confidence interval we're looking for. So we're saying is we're 95% confident that the true population mean for body temperature is between 98.08 to 98.32. So the question I mentioned we would discuss earlier is, well, where does 98.6 come from? So it's determined that 98.6, when we look at the true body temperature, since we're looking at to be like 98.2, that this body temperature of 90.6 is significantly higher than the average body temperature. And what 98.6 was established to be is the body temperature that people will have if they are sick or have a fever. So if you have a temperature above 98.6, that is the indication that your body is fighting some type of infection and that you are ill. So it's not, if this were the mean body temperature, think of it this way. If 98.6 was the mean body temperature, that would likely imply, assuming that it's normally distributed, that half the people would have 98.6 for a body temperature, and then half the population would be just walking around sick all the time, which we certainly hope is not the case. So 98.6 is a temperature that is a temperature well above the true population mean for body temperature. And it's a temperature that science has used for a long time to establish as the cutoff point from those who are not sick versus those that are sick when their body temperature is over that amount. So hope you found this video helpful, and feel free to comment or ask any questions if you have any. Thank you.